feel the vibe.
What's up, guys? Welcome back to another instructional video here for Algebra 2 with Mr. Gaines. We're going to finish up our Unit 6 on radical functions and expressions. So we've taken a look at radical functions and their graphs. We've looked at solving radical equations, and now we're going to kind of go back to radical functions, kind of the graphs of radical functions, but from an algebraic perspective. So just a quick lesson here. We're going to algebraically find the x-intercepts. Algebraically find the x-intercepts for each of the following functions. Let's make this also, let's find the y-intercepts. Let's find the x and the y-intercepts. I'm going to add a little bit to this. So algebraically find the y-intercept and the x-intercept, if they exist. Sometimes they may not. So y-intercept, we found these with polynomial functions, and so we can find these using the exact same techniques with radical functions. To find the y-intercept, we're going to substitute in 0 for x. So if I want to substitute in 0 for x, this is the same as 2 times 0 minus 3 minus 2. So what I would get here is 2 minus 3, which is the square root of negative 1. Sorry, I would have 2 times 0, which is 0 minus 3. So I'd get the square root of negative 3 minus 2. Now, yes, we could come up with an imaginary solution, but remember, we're trying to find parts of a graph here, and so an imaginary solution exists for h of 0, but for y-intercepts, the y-intercept does not exist because imaginary numbers will not show up on the Cartesian plane. So we do not have a y-intercept for this graph. Let's take a look at the x-intercept. To find x-intercepts, remember, to find x-intercepts with polynomials, you set the equation equal to 0 and solve. The same is true about finding x-intercepts for root functions. So I'm going to set this equation equal to 0, and now I'm going to use our solving techniques that we just discussed to solve. I'm going to add 2 to both sides. I'll take the square root of 2x minus 3 equal to 2. To get rid of my square root, I'm going to square both sides. So 2 squared equals 2x minus 3, which is 4 equals 2x minus 3. Now I can add 3 to both sides to get 7, divide by 2, and then I get x equals 7 halves, or 3.5. I can go ahead and check this on my graphing calculator. So let's go ahead and check this. I'm going to type my equation. Let's clear out what was in here before. I'm going to type my equation 2x minus 3, the square root of 2x minus 3 minus 2 into my calculator. Take a look at that graph. So we'll notice that it does not intersect the x-axis, the y-axis. If I take a look at really the x-intercept, I can find the x-intercept by doing second calc 0, making sure I'm on the left of the function here. The left of the 0, and then moving over to the right of the 0, and I'll find that that was at 3.5, which is 7 halves. So to find the x-intercepts and y-intercepts, we use the same techniques that we used for polynomial functions. So let's go ahead and take a look at another example. In B, we have the cubed root of x minus 4 plus 8. So finding the y-intercept is the same as substituting in 0 for x. So f of 0, which would be the cubed root of negative 4 plus 8. We cannot simplify the cubed root of negative 4 plus 8, and so this is as basic as our expression is going to get for the y-intercept. Now we can estimate that value if we want to kind of get a rounded answer for that. We could go ahead and in the calculator we can do the cubed root of negative 4 plus 8, and we're going to get approximately 6.41. So if you want to round your answer, you can, but also leave that exact expression down there just in case you need that exact expression. The x-intercept can be found by taking the entire function and setting it equal to 0, which is the cubed root of x minus 4 plus 8, I would subtract 8 from both sides to get the cubed root of x minus 4 equals negative 8. Then to get rid of the cubed root, I am going to cube both sides. So negative 8 cubed is going to equal x minus 4. Negative 8, most of us are probably going to have to use the calculator here. No shame in that. Negative 8 cubed is equal to negative 512, which still equals x minus 4. And then I would add 4 to both sides. And so I would get the x-intercept of negative 508. Now, to check this on the graphing calculator might be a little difficult, so I'm just going to check this by substituting it back in and making sure that expression is going to equal 0. So negative 508 minus 4 plus 8 does equal 0. If I want to graph this and check the graph for the y-intercept, that should show up on our graph. I can type in the function. So x minus 4 inside our cubed root plus 8. I'm going to take a look at the graph here, and you can see that it is going to cross somewhere around 6. If I go ahead and look at the table, I can look where x equals 0 and see that it's about 6.41, which is what we have. So we have found both x and y-intercepts for B. Now taking a look at C, same process. So to find the y-intercept, we're going to find t of 0, or substitute in 0 for x. So this is going to be negative 2 to the 4/3 power minus 16. Let's see if negative 2 to the 4/3 power simplifies nicely. You can do that by hand, but let's just save some time and type it into the calculator. And we're going to find that it does not simplify nicely, so this is going to go ahead and just be our expression. This is the exact answer. If we want to estimate that, that'd be approximately negative 13.48. Now, the x-intercept. If I find the x-intercept, I'm going to have x minus 2 to the 4/3 power minus 16 equals 0. So I'm going to have an addition of 16 to get my exponential expression by itself, or my rational exponential expression by itself. Then I need to get rid of the exponent that is the 4/3 power. And so this would be x minus 2. Sorry, our radicand here is not going to change. It's just going to be x minus 2 plus or minus 16 to the 3/4 power. So that 4 becomes the 4th root, so we have to take care of both positive and negative cases. Now we could do this by hand. The 4th root of, or we should be able to, the 4th root of 16 is 2 to the 3rd power, and you could rewrite this if you wanted to as the 4th root of 16 to the 3rd power. You don't have to, but the 4th root of 16 is 2, and to the 3rd power would be 8. So I would get plus or minus 2. Adding 2 to both sides, I would get 2 plus or minus 2. So what I'm getting here is going to be 4. 2 plus 2 is 4, and 0. Now, in the solving process, let's check for extraneous solutions. Be careful. So if I have 0 minus 2 to the 4/3 power minus 16, which was my, let's get that minus 16 out of the exponent. So minus 16, which was my original expression. I'm going to come up with a negative 13.48, which is not 0, so x equals 0 is not going to be a solution. I could do the same thing with 4, and it's going to give me the same answer. So 4 is not a solution. This has no solution, so the x-intercept does not exist. So it's kind of a lot of work to figure out that there is no x-intercept. We can check this here. We can check this by taking a look at the graph. So x minus 2 to the 4/3 power minus 16. If I take a look at this graph, I made a mistake. Whoops. Let's back this up. Hopefully you guys caught this. What I wrote down is an error here. Hopefully you caught my error. Hopefully you caught the error that the fourth root of 16 is 2. We got to cube that. This should be plus or minus 8. So then as I add 2 to both sides, I have x equals 2 plus or minus 8. And now I get x equals 10 and x equals -6. I'm not going to go ahead and recheck these. If you did check those, you would find out that both of those solutions would work. So if I want to check the y-intercept, I can find y equals 0 would be approximately 13.48. So here, and I can see one of my x-intercepts -6. If I scroll down a little bit, I can see the other x-intercept 10. So we can find x-intercepts and y-intercepts of radical functions similar to the way that we found them with polynomials. This is a good place to stop. Thank you guys for tuning in. I'll see you soon.